Today we are presenting our project titled MedVault, developed under the guidance of Mr. Raparthi Yashwant from Scope at VIT Vellore. Our team consists of myself, V. Yamini, Divyendu, Purvaja, Geeta Priya, and Monica.
In today's presentation, we will be discussing the introduction and importance of the application, related works, gaps and problem statements, objectives, existing models, proposed models, and conclusion and references. In today's healthcare landscape, one of the biggest challenges is fragmentation of patient data across different hospitals and institutions. This often leads to delay in treatment, miscommunication, and in some cases, even misdiagnosis, especially in critical situations where immediate access to medical history is essential. A blockchain based application, whether developed for the web or mobile platform, presents a powerful solution to this issue. By assigning each patient a universal unique ID, their complete medical history can be securely linked and accessed from everywhere. With this system, multiple hospitals can access and update patient records in real time using the same ID. So, even if a patient visits a new hospital or forgets to carry their documents, the doctor will still have access to their entire medical background. This not only improves continuity of care but also reduces redundant diagnostic tests. Furthermore, the use of smart contract and access control mechanism ensures that only authorized healthcare providers can view or edit sensitive information, maintaining data privacy and integrity. And because blockchain is decentralized, it is only naturally tamper proof, transparent, and ensures complete traceability. Unlike traditional systems, any changes to the data leaves a permanent and verifiable trail. Ultimately, this system enhances inter-hospital coordination, reduces administrative burdens, and provides immediate access to medical data, which is especially critical during emergencies. Importance of application. First, we aim to establish a universal patient identity system that enables seamless access to medical records across any healthcare institution. Second, we strive to enable secure and real time data sharing between hospitals powered by blockchain's decentralized and transparent nature. Third, we want to improve treatment accuracy and avoid unnecessary procedures by providing healthcare professionals with access to complete and up to date patient history. Fourth, through the integration of smart contract and role based access control, we ensure that only authorized users can access specific parts of patient data. We aim to protect against data tampering, unauthorized access, and any information loss by leveraging blockchain's immutability and encryption features. And finally, this system is designed to support emergency care by allowing instant access to verify patient data regardless of geographical location. In essence, this approach is only advanced patient safety and privacy by bringing us closer and more connected, efficient, and resilient healthcare system.
They studied research papers on the topic of blockchain based identity management systems for healthcare, and in related work, we have listed out six of those research papers. The first paper is titled Blockchain Based Decentralized Identity Management for Healthcare Systems by Arnav Aziz and Mohsen Tourani. And in it, they have proposed a decentralized identity management system named BDIMSS, and it is built on a permission blockchain that uses Hyperledger Indy and Hyperledger Aries. The features are data security, privacy, immutability, interoperability, and patient autonomy using selective disclosure and zero knowledge proof. It's decentralized, user centric, and passwordless, so passwords need not be remembered. It's highly scalable and interoperable. The challenges they have faced are it requires a client puzzle on client application to prevent denial of service attacks, and if the device that contains the identity wallet is lost, it may be there may be issues. It also has performance latency and degradation when there is high usage, as well as fluctuation when there is a lot of concurrent users. The second paper is an improved blockchain-based security medical record sharing scheme by Hussein Border and Imad Fakhri. It combines blockchain and document-oriented distributed database for secure electronic medical records, sharing and storage. It implements and compares different consensus mechanisms such as proof of work, proof of stake, and proof of access. The features are it ensures data integrity, privacy, and ownership with access control through smart contracts, and fragmentation based on data sensitivity, which improves the performance. There is no central authority, so the resistance to attacks is increased. The challenges that are faced are complex consensus tuning is needed for performance balance, as well as storage fragmentation will induce more overhead due to encryption and recombination. The next paper is titled Blockchain-Based Identity Management Systems in Health IoT, a systematic review by B. Alamri, K. Crowley, and I. Richardson. The methodology that has been adopted are off-chain protocols for the actual storage of data and smart contracts to build IAM access control logic, as well as identity wallet and a database. The features implemented in this is a decentralized identity for each patient, and every request can be tracked through smart contracts. The challenges that are faced is to ensure health-related data protection standards are met, as well as some contract programs are vulnerable to security attacks for bugs. The fourth paper is titled Enhancing Data Privacy in Healthcare Systems Using Blockchain Technologies by Sri Bhargav Krishnan, Adam Suli, Han Harini, and Arun. The methodologies adopted are it's using a Hyperledger Fabric, which is a permissioned blockchain platform, as well as a smart contract for role-based access. The features are smart contracts enforce role-based permissions automatically, and the encryption, AES encryption, will ensure that the healthcare data is secure as well as private. The challenges that are faced are latency overhead due to encryption technique, and the integration is difficult into the existing systems, as well as the security concerning storage of data, actual data off-chain.
So the author would be Hamid Taherdos, and the paper title is Privacy and Security of Blockchain in Healthcare, the application, challenges, and future perspectives. Let's see the adopted methodology. Critical evaluation of existing research, assess technical solution, reviewed security models and privacy frameworks. And the features are decentralized data exchange, immutable storage of medical data, smart contracts for automated access control, patient-centric data ownership. The challenges are interoperability issues between healthcare systems, scalability, limitations for large-scale data, compliance with regulations. The next one is Gianluca Lax, Roberto Nardone, Antonia Russo. The adopted methodology is decentralized indexing and identity, integration with identity provider, privacy, encryption, and automation. The features are stores hashes of patient records, consent status, and access logs. Ethical researchers can request anonymized data access. And the challenges are integrating with existing hospital system and MRIs. While blockchain is secure,
endpoints like clinics or identity providers can be vulnerable. Before designing a system, we studied the existing literature on blockchain in healthcare. Despite promising concepts, several critical gaps still persist. So the poor integration with healthcare system. Many proposed solutions don't integrate well with existing hospital infrastructure or fail to comply with essential healthcare regulations like HIPAA and GDPR. This limits real world adoption. Lack of recovery for identity wallets. In most models, if a patient's identity wallet is lost or stolen, there is no robust mechanism to recover access securely. This poses a serious risk to data continuity and ownership. Performance under load. Current systems struggle with latency and scalability, especially when handling large volumes of patient records during peak usage. This makes them impractical for wide scale deployment. Smart contract and storage vulnerability. Security of smart contracts and off chain storage, such as where the actual medical files are stored, is often underexplored. This leaves system vulnerable to unauthorized access or tampering. Next, the consensus tuning challenges. Achieving the right balance between security and performance using consensus mechanism remains a technical challenge. Poor tuning can lead to either slow response times or compromised trust. Based on these gaps, our problem statement is to design a blockchain based system for secure and unified access to patient medical record across healthcare institutions. The goal is to create a system that's not only secure and decentralized, but also interoperable, recoverable, and scalable, and standards compliance.
Objectives. The main objective of MedVault is to explore the potential of blockchain technology in enhancing healthcare data privacy and interoperability. Our goal is to develop a decentralized, secure framework for managing electronic health records, ensuring compliance with healthcare data protection. The system empowers patients with full control over their health data, allowing only selective sharing without relying on centralized authorities. By integrating smart contracts, we aim to automate key processes such as consent management and medical supply chain operations. Additionally, MedVault provides real-time tamper-proof access to authorized healthcare providers, along with them instant notifications to patients whenever their records are accessed or modified, ensuring transparency, security, and better coordination in patients' care. Thank you. Existing methodologies. It is divided into two main phases. First of all, indexing and accessing. On the left side, when a new e-health record is created, the patient generates a unique signature, a string that only they can produce. This signature is sent to the clinic, which links it with the corresponding health record and publishes this association on blockchain, making the tamper resistant and traceable. On the right side, accessing. When a healthcare provider, for example, doctor, needs to access the patient's record, the patient first authenticates through an identity provider, which issues an assertion, a token providing the patient's identity and consent. The doctor receives the assertion along with the patient signature and uses the blockchain to locate references to the patient's health record. The assertion then serves as a proof of authorization, allowing access to actual records stored in clinical systems. This setup ensures secure, decentralized indexing and controlled access to sensitive medical data while maintaining patient ownership and privacy.
MedVault is a blockchain-based medical record management system that ensures secure, patient-controlled access to health data. In this model, patients upload their encrypted medical records to cloud AWS. A smart contract layer logs patient consent on the blockchain, ensuring transparency. When a doctor needs access, they send a request via a doctor portal. The patient receives the request through MetaMask and can approve or deny it. Upon approval, the doctor receives a secure file URL via backend API to access the encrypted data. This system provides decentralized identity control using MetaMask. The technologies that are used here is for the blockchain platform, we use Ethereum, which ensures the immutability and transparent consent records using smart contracts. And for the front end, we use HTML, CSS, JavaScript, or React.js. For the backend, we use Node.js with Express.js, which handles the API logic, MetaMask integration, and smart contract integration. For the cloud storage, we use AWS, which stores the encrypted medical records off-chain for scalability and security. And for the database, we use MongoDB, which manages metadata, user details, and indexing hosted on the cloud. Therefore, to conclude, MedVault revolves around the healthcare by enabling secure, real-time, and decentralized access to medical records, making healthcare faster, safer, and smarter. Thank you.